So with the difference of two cubes, I'm going back to this formula, and I said I was going to do this, that this would be revisited, okay, on this test. The cube root of 27x cubed is 3x, which means my a is 3x. My b is my b cubed is 64, which means my b is 4. It's not 8, it's 4. And now I'm just plugging the a and the b in. 3x minus 4. The quantity 3x squared is 9x squared. You need to square both of them. 3x times 4 is 12x, and 4 squared is 16, and that is your answer. If I were to ask for the zeros here, 4/3 is a 0, and you'd have to plug this into the quadratic formula. Please keep in mind, you cannot factor this any further. But in this case, I'm just asking to factor, you just leave it. The second one is factoring by grouping. When you see 4 terms like that, a light bulb should go off in your head and think, I got to factor by grouping. My advice, put parentheses around the first 2 terms. Put a plus sign in and keep that middle term, or middle sign, with the 3rd term. And now I'm taking a GCF out. 3x squared, I'm left with, sorry about that. 4x squared, and we're left with x minus 3. A negative 2, and we're left with x minus 3. And then we're left with 4x squared minus 2, x minus 3. Now I gave this problem intentionally. Sometimes there could be a difference of 2 squares left behind. You'd have to factor that further. In this case, there's a GCF I can pull out of this one. This is the correct final answer. And before somebody asks me, could you have pulled the 2 out right away? Absolutely. Okay, I happen to pull it out right here. With 4 terms here, I'm obviously grouping. Okay. 4x cubed minus 7x squared plus negative 16x plus 28. Notice that middle sign stays with the 3rd term. We take an x squared out, and we're left with 4x minus 7. Here, we take a negative 4 out, and we're left with 4x minus 7. And now I'm left with x squared. We put the GCFs together, and 4x minus 7. And this is what I was talking about earlier, is that can you factor more? Always look for that difference of 2 squares. X minus 2, x plus 2, 4x minus 7. That's the one extra thing a lot of times that can come up that you can factor a little more. And my answers are going to be 2, negative 2, and 7/4. That 3x to the 4th, you're factoring it normally. The only difference is we get 3x squared and x squared. That's really it. Okay, and actually I should have my equal zeros here. Sorry about that. All right, and then my factors of 30 I'm going to use minus 5 and plus 6. And that'll get me to a positive 13x squared. There's nothing else that can be factored here, so I set them both equal to 0. This is the time you're going to want to write them out. Okay? X squared equals 5/3. We're taking the square root of both sides, so x equals the square root of 5 over the square root of 3. Right? We always square root the top and bottom, and yes, you need to rationalize the denominator. So my answer here is going to be plus or minus root 15 over 3. Okay, whenever you're taking the square root, solving for a variable, it's always going to be a plus or minus. Here is actually, even though it's a more complicated looking answer, it's actually probably simpler math. X squared equals a negative 6. When I take the square root of both sides, those are my four answers. Plus or minus root 15 over 3, plus or minus I root 6. The next higher level factoring, and look for difference of two squares here. You gotta look for it. You can't factor sum of two squares, but you can always factor difference of two squares. My answers are 5, -5, and then I gotta set x squared plus 1 equal to 0. X squared equals -1. Every one of us should know what the square root of -1 is. It's simply I. So it's plus or minus I, 5 and -5. And then my last one, x to the 8th, we're going x to the 4th, x to the 4th. In 25, I'll help you out because I'll use a smaller number on the test if I use this. X to the 4th, oops, I'm sorry, not minus 15. Minus 25 times x to the 4th minus 9. These are two difference of two squares. X squared minus 5, x squared plus 5. X squared minus 3, x squared plus 3. And you're setting each parenthesis equal to 0. X squared minus 5 equals 0. X equals a plus or minus root 5. X squared plus 5 equals 0. X equals a plus or minus I root 5. Plus 5 equals 0. X equals a plus or minus I root 5. X squared minus 3 equals 0. X is going to equal plus or minus root 3. And x squared plus 3 equals 0. X is going to equal plus or minus I root 3. And these are your 8 answers. Okay? You have x to the 8th. The directions tell you to do synthetic division, so that's what we're going to use. Whatever makes that parenthesis equal to 0 is what goes in the box. Drop the first term. 4 times 2 is 8. -9 and 8 is -1. -1 times 4 is -4. -2 and -4 is -6. -6 times 4 is -24, and that's 0. So 2x squared minus x minus 6. And we factor what's left. 2x plus 3, x minus 2. Those are the factors of that. Okay? And we're given x minus 4. I probably will on the test, I only ask you to factor, I'll ask for the zeros as well. So what makes each of these parentheses equal to 0? -3/2, 2, and 4. I probably will ask for the zeros as well. The second one, same type of problem. We're putting 5 in the box. 3, 5 times 3 is 15, we get 11. This is 55, we get 6. This is 30, we get 0. And we factor what is left. 3x squared plus 11x plus 6. And we get 3x plus 2, x plus 3, x minus 5. -2/3, -3, and 5 would be my zeros. Now solving for k, particularly when you're given something as a factor, we're kind of working backwards here. If something is a factor, that means the remainder is 0, and therefore this has to be 40. So that means 4 times whatever number is here has to equal 40. So right away I can put this number down as 10. Okay? And now we go the other way. Drop the first term, that's 2. 4 times 2 is 8. -1 and 8 is 7. 7 times 4 is 28. what does k have to equal to give me a positive 10 here? So essentially, what does k have to equal if you add it to 28 to equal 10? Well, that's a negative 18. I'm going to put negative 2 in the box, and it's 1, 5k, and negative 60. It's a factor, so this has to be 0, which means this has to be 60. What times negative 2 would give you a 60? Negative 30 would. So I have all the information I can get on the back end right now. Drop the first term, we get negative 2. 5 and negative 2 is 3. 3 times negative 2 is a negative 6. So k minus 6 equals a negative 30. K equals a negative 24. And that's how we go through it, synthetically. So here, it does not matter which one you do first. I'll do the 2 first. But once again, it does not matter. Drop the 2, we get 4. 15, we get 30. 31, we get 62 here. 12, we get 24, and we get 0. We need to use the depressed equation. And what makes that x plus 3 equal to 0? Negative 3. 2, 15, 31, and 12. Drop the 2, we get negative 6, and it's 9. We get negative 27, and it's 4. We get negative 12, and it's 0. And I'm taking that new depressed equation, and once I can get to something I can factor, we want to factor it. Okay? Once we can get something we can factor, we want to factor it. This factors to 2x and x, and my factors of 4, if I put the 1 here and the 4 here. Remember, the 4 with the 2 would be no good. It'd give you a GCF anyway. That's its factor. 2x times 4 is 8x. 1 times x is 1x. That gives me my 9x. And you include the other 2 factors. X minus 2, x plus 3. So my factors, negative 1/2, negative 4, 2, and negative 3. And this is all given information, basically. All right, we'll start with this one with the 1, 3, negative 8, negative 21, 18, and 8. Drop the 3. We get negative 5. Negative 5, we get negative 26. Negative 26, I get a negative 8. Negative 8, I get 0. 4, 3, negative 5, negative 26, negative 8. Drop the 3, we get 12. 28, we get 2. 8, we get 0. And I'm factoring what is left over. 3x squared plus 7x plus 2. It's a pretty basic factoring because it's got to be 3x and x. The 1 goes here, the 2 goes here. 3x times 2 is 6x, 1 times x is 1x, 6x and 1x is 7x. And then I bring down the other 2 given factors. X minus 1, x minus 4. So negative 1/3, negative 2, 1, and 4 are my zeros.